Alright, welcome back to another video, and this will be a continuation of exponent and logarithm videos that I had previously. If you haven't checked that out, make sure you do so, because I talked about rules and regulations and formulas that you need to apply. But today we're focusing on equations, not the rules, the equations itself. Finally, we can see, how the rules that we have learned, they're not just there to solve or simplify things, but actually find the unknown, which is what we really care about, right? Now, there's not much to talk about in terms of theory, but I do want to mention a few things before we jump into examples. Whenever you're dealing with an exponent equation, we'll get to the logs in a second. Whenever you're dealing with exponent equation, what I like to tell my students is always try to bring it into the same base, right? Which is not my invention, by the way. But if you can bring it into the same base, then the rest is easy. The rest you solve like a linear equation. Now, it could also be a quadratic equation. It doesn't matter. What do I mean? For example, you have a to the power of, let's say, 2x equals to, let's say, a or 1 over a to the power of, I don't know, let's make it square, a 4x. Okay, now you look at this question and this looks scary because you don't know where to start. But like I said, the good place to start is make sure you bring them into the same base. Now the left side is already nice. It's a to the power of something, 2x squared. Let's see if we can do the same thing for the right side. So if I have a 1 divided by a 4x, using the exponent rules that I have talked about in the previous video, make sure you check that out if you haven't, I can write it as a negative 4x, right? Now, if I write a negative 4x, now I have same base. A very simple version of it would be this. If you have 2 to the power of 3 equal to 2 to the power of x, you would safely assume that 3 has to be equal to x, or x has to be equal to 3, right? The idea is the same. If the bases are same, we can just treat them like a regular linear or quadratic equation, meaning 2x squared needs to be equal to negative 4x. Okay, and then you can try to solve it. You can do a couple things. I don't know. You can treat it as quadratic equation, find discriminant, or you can factor out x. Whatever the case is, it doesn't really matter. The goal is to bring it into the same base, then solve it like a regular equation. It's not an equations video, so I won't get into that, but we'll do some examples for sure. So I have the rules here again. Always keep them in front of you so your eyes get used to it. Let's look at this one. First one says 25 to the power of x plus 1 equal to 5 to the power of 3. Now, if you are good with numbers, hopefully you are, you can recognize that 25 and 5 has some sort of relationship, right? So, meaning 25 is actually 5 squared. So we can bring them into the same base. I'll write it here. 25 can be written as 5 to the power of 2, x plus 1. And then, using the power rule that I have here, I can write it as 5 to the power of 2x plus 1, right? Equals to 5 to the power of 3, according to the equation. So, now I can ignore the 5's, and I can just look at 2x plus 1 equal to 3, right? And from here, x is going to be, I believe, negative 1. No, just 1. Just 1. Okay? Let's try this one. 25, again, I know 25 is 5 to the power of 2. In fact, it's the same as the top, so I'll just write it directly. 5 2x plus 1, right? Actually, I did it wrong. It should be 2x plus 2, right? Yes. It should be 2x plus 2. So x is going to be here. What is x going to be? 1 over 2. 1 over 2. Okay, so this is 2x plus 2, again, based on the power rule. And the right side can be written as what? I need 5 to the power of something. So the bases are same. 1 over 5x again, we can use the negative exponent rule. Can be written as 5 to the power of negative x. Okay, from here I can just solve a linear equation. 2x plus 2 equal to negative x. 3x is going to be equal to negative 2. X is going to be negative 2 over 3. Fair enough? Okay, I'm going to do C here because I don't think there's a lot of space up there. So again, 25x plus 1 is still the same. So I'll write 2x plus 2. And what can we do with square root? There is a fractional exponent rule. Again, we talked about it before. I can write it as 5. Square root of 5x can be written as square root of, sorry, no square root. 5 to the power of x minus 2. Pay attention, m and n here. Okay. Now, again, I end up with a linear equation. So 2x plus 2 is equal to x divided by 2. Multiply everything by 2. 4x plus 4 equal to x. And then x is going to be equal to negative 4 over 3. D. 25x squared equal to 125x. Again, we're looking for same base. I know I'm repeating myself 10 times, but it's really that important. So 25 and 125. Can we write it as either 5 to the power of something or 25 to the power of something? Let's see. 25, easy. We can write it as 5 like that. Now, what is 125? What's 125? 125 is 5 times 25, x. Okay, I can open the right side a bit more. I can say 5x times 5 to the power of 2x, right? And that's 5 to the power of 3x in total, not 5, 3x. Now, you could potentially see that 125 is 5 cubed as well. That would be great if you did. Yes, but if you didn't, you could treat it this way as well. So what do I have here? I have 2x squared should be equal to 3x for this equation to be correct. And then I can solve it now. What can we do? We can factor out x after moving 3x to the left. I'll have 2x minus 3 equal to 0. This has two solutions, right? x1 is 0. And x2 is going to be 3 over 2. Okay, you can test it out and check for yourself. So the last one, I have a little space here. I'll use that. I'll use the red marker so we can see. Now, what is 1? 1, 1 is 1, but 1 can be written as anything to the power of 0 according to the 0 exponent rule, right? So I have a 7 on the left side, so why not use that? So 7 to the power of 0. Good? That means x squared minus 5x has to be equal to 0. And then, if I solve that, I'll get x1 equal to 0 and x2 equal to 5. Okay? Either one will work. Now, when it comes to the logarithmic equation, the idea is pretty much the same. The idea is pretty much the same. For example, if you have log a x plus log bx. There is not much we can do here, right? Because the bases are different, so we cannot use any of the logarithmic rules that we know. So somehow we might need to bring it into the same base. Now, some questions you will see that they already have a same base. So log a x minus log a, 2x plus 3 equal to something. Equal to 1, something like that, right? This is very nice because the bases are the same on the left side, and 1 is not a logarithmic expression, but it can also be written as log AA, so that everything has the same structure. So you can think of it as like a common denominator for fractions. I talked about that as well in the previous videos. Okay, bringing into the same base, then all the logarithmic rules will apply. So I want to work on examples with you on this. Okay, we start nice and easy. log base 3x plus 1 equal to 2. We have a log rule that we remember, hopefully, that b is always equal to a to the power of c. So first one, b is what? X plus 1, right? Has to be equal to 3 to the power of 2, which is 9. And then x is going to be 9 minus 1, which is 8. These are a bit simple ones, but it'll get better. Next one, I don't see any base here, which scares me for a second, but then I remember that if I don't see any base and it's written as a log, not ln, we'll come to the ln in the next one, it means base is 10. So we have actually log 10 x plus 1 equal to 2. Again, I'm using the rule that I have here. X plus 1 has to be equal to 10 to the power of 2, which is 100. Right? So x is going to be what? 100 minus 1, which is 99. The last piece, ln x plus 1, again, ln means log e x plus 1 equal to 2. Then x plus 1 is going to be e square, and x is going to be e square minus 1.